Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, functions in mathematics, what we are going to discuss today is a composite function. So let's begin. After completing the very lesson today, my dear student, will be able to define what is a composite function, and you also be able to find the image of an element under a given composite function. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, your favorite segment of the lesson that is more fun today, I'll give you another interesting number. This number is 65. 65 is so interesting, so amazing. I will explain what is interesting with this very number 65 after completing my lesson today, so don't go away. So to begin the lesson, my dear student, let me define what is a composite function. And for me to do that, let's just consider these two functions, f and g. You have a function f that takes each and every element in the very first set x and assign it to a single element in the second set y. And another function g takes each and every element in the first set y and assign it to a single element in the second set z. And if these were functions and those functions are defined by the diagram below, let's see the diagram. So this is the diagram. You can see x as the very first set as far as the function f is concerned. And that under this function f, it takes each and every element in the set x, assign it to a single element in the second set y. But looking at g, even from here, you can see the domain of g is now y, which is exactly the same as the codomain of the function f. You can see y is common. Y is common. Look at the two sets, y is common. Under the function f, y is codomain. But under the function g, y is domain. And you can even see from this drawing. If you take this side, is now the function f, and if you take this side, is now the function g. So you can see g takes from y into z, but f takes from x into y. So y is now at the middle of the two. Y, they share y in common. So if there is another function that did this double assignation, that is from x into y and from y into z, instead of this double assignation, if there is a single function that is just did one single assignation from x directly into z, it is that function that we call the composite function of these two functions f and g. Let me just have a similar drawing that having just one function that this double assignation just by one assignation. This is the function from x into z, from x into z. And if you look at, for example, this element a in the very first set that were assigned to 2 under the function f, and this element 2 under the function g is now assigned to this 30. Look at it, but in the combined function, you can see this a assigned directly to 30. So here, if there is a function, like I said, that will now do this double assignation of these two different functions from x into z, that is a mapped to 30 directly, just like you have seen here. It is that we call the composite function of the two functions. So this is a g of f. G of f, meaning it is a combination of these two functions by just having one function, and we call it a composite function of g of f. G of f. The last function will now come first. Then the first function will now come last, because here it is first f, then the letter g. But in the combination, you now have the last one first, then the first one last. That is g of f. G of f. So let's just proceed. Still on this. So if you have the function g of f, that is the composite function, is now called the composite function from x into z, like I have explained, and is defined by this formula, g of f of x to be equals to g of bracket f of x, which means you have to find f of x first. Whatever the result is, you now find the g of that very result. So from this above, we can see that if we are to find f of a first, it will give you 2. And that 2, you now find the G of 2, it will now be 30. But for this is now saying just G of f of a, it will now just give you 30. Let me just write it. Let me just write it. So you have G of f of a to now be 30. And this is exactly the same thing as G of f of a. That is, you now to find f of a first. F of a, that is the image of this element a under the function f. That gives you 2. And now again find G of 2. That is finding the image of this element 2 under the function g, which gives you 30. So you can see G of f of a, which is the same thing as G of 2, and which will now be 30 finally. And this is exactly what we have using this composite function. Example number 1, it says let f of x equals to 2x squared plus 5 and another function G of x equals to 4 minus 7x. The question asks is to find the question number A, f of G of 2, and the question number B, it says G of f of 2. These two might be different. Let's just see solution to this very problem. So starting with the very first question, that is question number A, to find the f of g of this element 2. What we now do first is find the g of 2. That is f of g of 2 will now be equals to f of bracket g of 2. Let me just move. So I'm to find the g of 2 first. So I'm now going to have f bracket g of 2 inside the bracket g of 2. So I'm to find the g of 2 first. Whatever comes last is what you do first. So to find the g of 2, meaning the image of this element 2 under the function g, I will now go to my function d. Look at it, g of x equals to 4 minus 7x. I will now replace the x in this formula by this number 2. Whatever I have finally will now be the image of the element 2 under the function g. Let me do that. So I'm now going to have f bracket 4 minus 7 times 2. I have replaced this x in the function g by this number 2. So simplifying this, 7 times 2 gives you 14, and you have 4 minus 14. That will now give answer minus 10. So minus 10 is now the image of this element 2 under the function g. So what I will now do, I will now to find the f of this minus 10. To do that, I will now just move to the function f, which is says 2x squared plus 5, and substitute this minus 10. Whatever I have finally will now be my answer. So I'm going to have 2 multiplied by minus 10 raised to the power of 2. I have replaced this x by this minus 10 in this very formula f of x. So I will now simplify this. Minus 10 square will give answer 100 times 2, 200. 200 plus 5. The final result is now going to be 205. So this question A has been answered. F of G of 2 will now be 205. So I'll now move to question number B, where we asked to find G of f of 2. You see the two results might be different. So what we are to do, if it were G of f, then we now find f of 2 first. Let me just write it. This will now be the same thing as G of bracket f of 2 inside the bracket f of 2, which means I'm to find the image of this element 2 under the function f. Then later on, whatever I have as the image, that will now act as a member in the domain under the function g. Let me do that. So to find this f of 2, I'll now go to my function f. So replace the x by 2 in the function. Then I'm going to have g outside, then 2 times the 2 square. I have replaced this x square by 2 square, then plus 5. 2 square will now be 4 times this 2 will be 8, then plus 5. That will give answer 13 finally. So this is g of 13. That is the image of 2 under the function f is now 13. So this now 13 would now be an element in the domain under the function g, in which I want to find its image in the codomain. So to find the g of 13, I'm now move to the function g, substitute this x by the number 13. So I'm going to have 4 minus 7 times 13. And when you do this correctly, you now have minus 87. This will now be the final result, that is g of f of 2. Let us move and take another example. Example number 2, it says let the function f of x equals to 2x minus 1 and another function called g of x equals to x plus 3 all over 2. The question asked is to find a f of g of x and b g of f of x. So which means we have to find the formula that defined this composite function. So let's do that. Solution to this very problem. Starting with the very first question, that is A, to find f of g of x. Like I have said, we have to find a formula that when substituted any value, it will do this double assignation. That is the formula for the composite function f of g. F of g of x will now be equals to f bracket, inside the bracket is g of x, which means it's g of x that I'm going to do first. And my g of x, remember, this is the function g of x plus 3 all over 2. So I'm now going to have f of x plus 3 all over 2. I have replaced this g of x because it's nothing but x plus 3 all over 2. So I'm now going to take this and substitute instead of this x in this very formula f of x. Let me do that. I'm going to have 2 instead times this x. I will now put this instead, x plus 3 all over 2. So we have 2 times x plus 3 all over 2, then minus 1, this minus 1. So you now simplify this very problem. You can see this 2 cancel this 2. So you now have x plus 3 minus 1. And when you collect like times plus 3 and minus 1, it gives you x plus 2. So this is the new formula for this composite function f of g of x. F of g of x is now defined by this formula x plus 2. And this is what exactly we are asked to do in this very question. Let me just move to question number B. Question number B, we were asked to find the formula for this composite function g of f of x. So there, the function f last, I will now do it first. This will now be equals to g of open bracket inside the bracket f of x. And this f of x, if taken as 2x minus 1, I will now try to find the g of bracket 2x minus 1. So I'm now taking this 2x minus 1 as just an element that I want to find it is image under the function g, in which we said we'll now go to the function g and replace the letter x by this very element. This 2x minus 1 is now acting as an element that I want to find it is image under the function g. So I'll go to function g. Instead of that x, I will now replace it by this. Let me do that. So I'm now going to have 2x minus 1 that I have replaced this x by 2x minus 1, then plus the 3 which I copied all over 2, which I also copied. So I'm going to simplify this. So opening the bracket, I will now have 2x plus 2. That is minus 1 plus this 3 gives you plus 2. If I continue, I think it's simplifiable. 2 can be factored out here in the numerator. So when that is factored, you now have 2 outside and then x plus 1 plus inside the bracket all over 2. And this 2 will now cancel this 2. You now have x plus 1 as the formula for this composite function g of f of x. Example number 3 says let f of x equals to square root of 2x plus 1 and another function g of x equals to x squared plus 3. The question asked here if we are to find f of g of x, that is the formula for the composite function, and use that very formula to find f of g of 3. So solution to this very problem. So let's start with the formula. It's just what we have done in example 2. So starting with the f of g of x, like here I said, we are to find the formula for this composite function f of g. Is g last, so it's g that I'm going to treat first. So this is nothing but f open bracket g of x, that is f of g of x. And this g of x is given by this formula x squared plus 3. So now have f of, I will replace g of x by x squared plus 3. So this x squared plus 3 is now acting as an element that I wanted to find it is image under the function f. So which means I'll now go to the function f and replace the x by x squared plus 3. Let me do that. So I'm going to have root of 2 times x. Instead x, I now have x squared plus 3, then plus 1. So simplifying this very formula, simplifying this further by opening this very bracket, 2 times x squared gives you 2x squared, and 2 times 3 gives you plus 6, then copy your plus 1. And if you continue, 6 and 1 can be collected together to get 2x squared plus 7. So this is the new formula for this composite function. So we are going to use this very formula to find the f of g of 3. Let me do that. So to find the f of g of this number 3, I'm just going to use this very formula directly. I will now replace the x by the number 3. Whatever I have finally will now be the f of g of 3. So let me just substitute here. So I'm going to have root of 2 multiplied by 3 square. Instead x square, you now have 3 square, then plus 7. 3 square will be 9. 9 times 2, that gives you 18, or 18 plus 7. Let me do that. That will now give you square root of 25, and square root of 25 can be evaluated to get plus or minus 5. This will now be the f of g of 3. And this is how we now find either an element under the composite function or the composite functions, the formula for it itself. With this, my dear student, I have come to the end of this very lesson. I hope you find it resourceful. And let me just move to the last segment. Maths is fun, and explain what is interesting with the number 65. 65 becomes a square number when both it is reversed, is added, and is subtracted. Let's just find out and see. 65, if we add it is reverse. Reverse of 65 is 56. If you add this reverse to 65, you get 121. So what this property is saying, this 65, when you add it is reverse, it will give you a square number. Similarly, when you subtract it is reverse, it will still give you another square number. Look at this 121. 121 is a square number because it's nothing but 11 raised to the power of 2. So 121 is a square number. Let's just subtract the reverse of 65 from 65. That is 65 minus 56. 56 is the reverse. So if I subtract it, it will give me 9. And the 9 is 3 square, so 9 is another square number. This is really interesting with this number 65. We see more of these things in mathematics in our subsequent lessons.